Comets are frozen leftovers from the formation of the solar system composed of dust, rock, and ices. They range from a few miles to tens of miles wide. Comet 2I Borisov is the first confirmed interstellar comet. 2I Borisov has a heliocentric orbital eccentricity of 3.36 and is not bound to the Sun. The comet passed closest to Earth on December 28, 2019. The typical comet is about 10 kilometers in size. 2I Borisov's tail is a staggering 14 times the size of Earth. It's humbling to realize how small Earth is next to this visitor from another solar system. NASA recently unveiled a picture of a strange object that appeared to have come from another solar system and was distinct from anything you've ever seen. The second known object to have traveled outside of our solar system. A distant spiral galaxy can be seen off to the side of the comet in the picture. The Hubble Space Telescope followed the comet across space and caught the image's vivid blue center. The image depicts the comet as it travels through our solar system. Gennady Borisov, an amateur astronomer, first spotted a moving object on August 30, 2019 while looking upward through his homemade telescope. This roving spot of light, now dubbed 2I Borisov, turned out to be the first comet to be positively identified. The second extraterrestrial object from a location untouched by our Sun to come reach our solar system. In an effort to discover as much as they could about the interesting visitor, astronomers from all over the world gathered to examine the object with some of the most powerful technologies available. Astronomers have discovered that 2I Borisov has an unusual composition due to observations made with the Hubble Space Telescope and the Atacama Large Millimeter Submillimeter Array ALMA of the National Radio Astronomy Observatory. In particular, it has more carbon monoxide than any comet that has been seen very close to the Sun, or within around 300 million kilometers. Scientists' methods to determine that the comet may well have originated around a red dwarf, a smaller, fainter type of star than our Sun, although other sorts of stars are also plausible. Another hypothesis is that 2I Borisov is a small planet fragment rich in carbon monoxide. Comets are roughly the size of a small town when completely frozen or inactive, but when heated by the Sun their ends can stretch for millions of miles. 2I Borisov is approximately 9 football fields in length or 0.98 kilometers. Nature Astronomy has published the most recent findings regarding the comet's makeup. The early material disk surrounding a forming star, where comets are born, contains remnants of the planetary system's distant history. Comets from our own solar system provide a history of the element that gave rise to Earth and its other planetary neighbors, including water. An interstellar comet, in contrast, is a chemical messenger from a totally different star system and contains a plethora of knowledge about planets that are too far away for space travel. 2I Borisov was born in a different star. It might be more recent than our 4.5 billion-year-old planetary system or more ancient. The vast majority of comets that were created around our Sun have been expelled from our solar system by gravitational interactions with Jupiter. It is possible that Borisov was similarly driven out of its own system. Although the surface of Borisov hasn't been directly observed, comets that travel through our solar system have rough surfaces. Borisov is too tiny to sustain its own atmosphere and is occasionally coated in ice and dust layers. It lacks sufficient material or mass and as a result gravity. However, Borisov has developed a coma, a dust-filled cloud of gas surrounding the comet's nucleus. A coma is formed when ice is heated by solar energy and dust brushes off the comet's surface, and into space. Professor of Astronomy and Planetary Science at the University of California, Los Angeles David Jewett, whose team captured the best and sharpest images of this first interstellar comet. He clarified that Comet Borisov's core, which is its most important component, may be best estimated by Hubble with the greatest degree of accuracy. Their Hubble images reveal that its nucleus is considerably smaller than earlier research had hypothesized. Almost 15 times smaller, the radius is not more than 500 meters, significant because figuring out the size allows them to estimate the total number and mass of these objects in the Milky Way. In the solar system, Borisov is the only interstellar comet observed. We all would like to learn how many more there are. Borisov was created in an entirely other star system than our Sun and its family of planets. Maybe be a different age than our planetary system. The majority of the time, planets that were born around our Sun have been expelled from our solar system by gravitational interactions with Jupiter. Researchers discovered something unusual inside the comet's gas halo. More carbon monoxide was being released by 2I Borisov than any other comet seen at a comparable proximity to the Sun. NASA's Hubble Space Telescope later confirmed this, too. Could this be our first look at the chemistry of another planetary system, scientists wondered. Or are we finding that comets have a wider range of chemical composition than we previously realized? One of the most common substances in space is carbon monoxide. Scientists anticipate finding it inside every comet, yet there is a significant variety, which is perplexing. Whatever the case, 2I Borisov is fantastic. The comet probably formed in one of the coldest conditions known to man, quite far from its star, to retain its carbon monoxide. In our solar system, this would have been in the vicinity of Neptune. When comets were forming, temperatures there would have reached -420 degrees Fahrenheit. Scientists speculate that 2I Borisov may have been driven out of its native star system and into a frigid, lonesome journey due to gravitational disruptions from young, jostling planets. We therefore have some idea of what 2I Borisov is and isn't, despite the fact that scientists want to learn more about it in the next years. We do, indeed. As was already mentioned, we are aware that it is a comet, which is significant because it helps highlight the interstellar object visually. For instance, the coma was the very first indication that the object was a comet. For those who are unaware, the fuzzy portion of the comet that you observe is its coma. It moves about the room. It actually begins to work when the rock is exposed to the sun. The comet begins to partially melt as a result, giving rise to the fuzzy appearance. The comet has migrated through space, making it more difficult to determine its size. Depending on the equipment employed to observe it, estimates of its size have changed. In the end, we think the comet's nucleus is between 1.4 and 6.6 kilometers in diameter. It is significant in light. It resembles a comet in every way that you could expect to encounter one in the universe. This one just happens to be tearing through star systems.